Hey, welcome back, everyone. A couple quick things, and then I'm going to dive right in. I'm going to try to keep this video even shorter. One, hope you all are having a great week. As always, take some time to be thankful, to be reflective. There's so much to be thankful for in our lives, so make sure you take a little bit of time to do that. All right, speaking of thankfulness, you have the opportunity to retake any of the 6 assignments that we have taken to date while distance learning. So if you have not done any of these assignments the first time, if you have an N in the grade book, or you don't like the grade you have, feel free to retake these. These are all due by this Friday at 8 a.m. So don't wait till Friday morning. Try to get it done beforehand. As always, I am available via Google Hangout, or email. Just shoot me an email. We can jump on a video chat, 5-10 minutes, and get you where you need to be. All right, guys, I'm going to jump over real fast to this. So we are going to do completing the square part 2. We're going to just stay with this. I've gotten a little feedback, and there was some confusion as to how this is actually happening. So we're going to walk through a couple more examples today and give you a few more practice questions. All right, so I just want to walk through this first. So the first thing that we're going to do is move this constant. So this is this -7. We're going to bump it over, all right? And then this creates a space right here for us to complete the square, which means that if we were to actually draw a square with the dimensions of x plus or minus something, it would be a perfect square, meaning both sides are the same. I guess all 4 sides are the same. So this part right here, there's a lot happening. So I'm going to walk over to my notebook paper, and we're going to walk through an example that I gave you for homework. So I'm going to jump off here. Have a great Wednesday, Thursday, and I will see hopefully all of you on Friday at 1 o'clock. That's when I do my weekly touch base via Google Meet. I'd love to see you all there. We can talk math or anything else. All right, until Friday, say goodbye to my face. Okay, so take a look here. I'm going to look at this question. We're going to do the second one right here. So x squared minus 6x equals 9. So let me bring you here. Okay, so this was number 2 on your homework. Okay, so the constant, the c value is already over here. So there's the space for us to complete the square. Okay, so looking back at the steps from part 1, we have moved the constant from the left side over to the right. That's already done. Now we're going to take a look at this b value. This b value is also called the coefficient of x, right? Every number in front of a letter is considered a coefficient. All right. The second step said to take that b value, which is -6, and we're going to divide that in 2. Okay. And that's going to give us -3. Also in the second step, it said to square this. So take that -3, square means to multiply it by itself. That's going to give us 9. Okay. And then the third part of that second step, it was 3 parts in one, which was a lot. It says to add the 9 to both sides. So we're going to say plus 9 and plus 9. Okay. So I'm going to show you what this means. Okay. So we're going to factor this. And we've done that before. So our a value, which is 1, times our c value. So 1 times 9 equals 9. We're going to factor this. So that means we need to find factor pairs that multiply together to be 9. And 3 times 3. Okay. Now, remember, when factoring, we want the product or the multiply, or the number that we get when we multiply 2 factors together to be 9, positive 9. But then we want those values to add together to be -6. Well, to make anything here be -6, it has to be a -3 and another -3, okay? Which happens to be the value here when we took the original b value and divided it by 2, okay? So that's important. So now we have our 2 factors. Remember, we would come over here and we would rewrite this. I'm going to come here. We would say x squared and then we would plug in minus 3x and minus 3x, and then plus 9. Okay, so here we were taking our negative 6x and just rewriting it as something different so that we could factor the front binomial and the back binomial. Okay, and then I won't forget this. This is over here. This is 18. Okay, so what these have in common is just an x, which leaves an x minus 3. And when I factor something out, that's me dividing it out. So x squared divided by x leaves us with x. Negative 3x divided by x is negative 3. Okay? All right, so this is done. Then I'm going to say, well, what does this have in common with this, right? Well, the answer is negative 3. So I'm going to divide out a negative 3 or factor out a negative 3. If I divide this term by negative 3, that leaves me with x. And 9 divided by negative 3 is negative 3. Remember from our factoring back in Unit 6 that we'll put these two things back together. So this is x minus 3. And then our other binomial is this x minus 3. And all of that equals 18. Okay? And then this can be rewritten. This is repeated multiplication. So this is just x minus 3 squared equals 18. Right? Then we would take the square root of both sides. Okay, and we'll talk about that in just a moment. But I want to bring you back over here. When we're completing the square, right, we follow these steps. So we take the b value divided by 2 to get negative 3. And our rule here is whatever we get for b divided by 2, so b divided by 2, this is our b value, that is going to be the value that we add or subtract to x, or subtract from or add to. So x, this is what we got, minus 3 squared. Okay, because we're completing a square, which means both sides are going to be the same. So we have the same binomial being multiplied by itself. Okay, equals 18. All right, so this goes back to lesson 7.2. So we take the square root of both sides. That leaves us with x minus 3 equals the square root of 18. Now, there was some confusion here. Originally, I said to get this in simplest radical form, we want to divide by perfect squares. Well, the problem with that is some of you may not remember what perfect squares are, simplest radical form. And that's why we wrote them down. So I'm going to come over here. So 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. Then 25. Then 36. Okay, and we took those all the way up to 100. But that may or may not work for you. So I'm going to show you another way. One of my fellow Algebra 1 teachers recommended this, and I agree that this is a good idea. So take that value inside the radical. We're going to create a factor tree with it. So it's even, so I'm going to say 2 times 9. Okay, and then this can't be broken down anymore, but 9 can be, and it's a group of 2 3s. Okay, so you circle where you have a pair, and then this 2 is just left by itself. Okay, so the square root of 3 times 3, which is 9, is just one of these 3s. Okay, so I'm going to say plus or minus that 3. Remember, the square root of any number can be a positive or a negative. But this 2 didn't have a partner, so it's stuck under the radical. Okay, so that helps us simplify the radical. Okay, so that it's in simplest radical form. Okay, last step here is add 3 to both sides. And I'm going to jump down here. Okay, so then this leaves us with x equals positive 3 plus or minus 3 square root of 2. Okay, and we can go and add 3 to this and find an approximation, and then say 3 minus this and find another approximation. But the question itself on the homework said leave it in simplest radical form. Okay, so that would be our answer. All right, so that was from the homework. Now I'm going to jump over here and show you, I'm going to do 2 more problems for you as part of our next lesson. All right, so here's our lesson. I'm going to skip number 1, and I'm going to jump straight down to number 2. Okay. All right, so number 2 says In fact, I'm going to jump down to 3 because it's going to allow us to practice this factor tree. So this is x squared plus 4x equals 50. Okay, so let me jump back over here to my notebook paper. All right, so this is the next example I'm going to do for you. And I'm probably going to stop here so as to keep this video short for you all. Okay, so I left the space here so that we could complete the square. Okay, so this is our b value. And our steps for completing the square say take the b, divide it by 2. And our b value here is 4. We're going to divide that by 2, which is 2. Now, remember, whatever we get for b divided by 2 is going to be what we put in our x plus 2 squared binomial, right? So this is positive 2, okay? And we could find this right here by factoring with our a times c method that we learned several weeks ago. Okay, so let's finish this. Then the steps say take that 2 that we got, square it. It gives us a 4. And then we're going to add 4 to both sides of the equation because we can't change one side without changing the other side. Otherwise, we unbalance the equation. All right, so we've got this. This is easy. I'm going to jump over here now. So we know that this is going to be x plus 2 squared. Remember, because we know that whatever b divided by 2 is, which is 2 here, that is the value that we add or subtract from x. Add to or subtract from. Okay, that's just a rule with completing the square that we are able to memorize. All right, and then the right side of the equation is 54. All right, well, we did this in 7.2, so take the square root of both sides. That leaves us with x plus 2. And here's where we're going to try to get this in simplest radical form, okay? So 54, I can go divide it by these perfect squares. So it is divisible by 1, not divisible by 4. It is divisible by 9. So I could do that, but I'm going to show you the factor tree way again. So I'm going to take 54. It's even, so I'm going to break it down into 2 times 27. 2 can't be broken down anymore. 27 can be. Most of you will have this multiplication fact in your head, but if not, you're welcome to use the calculator. But most of you can come up with 3 times 9. And then 9 has to be broken down into 2 3s again. Okay? So wherever you have a pair, because remember a square root is asking for 2 of the same number, right? So the square root of 9, which is 3 times 3, is just 1/3. So that is what I get to pull out up here. So plus or minus 3. But then I have a single 2 and a single 3 left. Well, since all of these were multiplication, I'm going to take those 2 values and multiply them together. So 2 times 3 is 6. So that is the part that's left under the radical. Okay, so now this is in simplest radical form using a factor tree. Last step we have is to subtract 2 from both sides. And then we're going to write it one last time. So we have negative 2 plus or minus 3 times the square root of 6. Okay, and that would be our final answer. Okay, so I'm going to stop the video here. I would love to do a Google Meet or Hangout with any of you that need it. But take your time on these examples. Review factor trees. Okay, and I've kept the video shorter than usual so that you have more time to explore yourself. Okay, so pause the video as needed. Here is your attendance ticket for the day, or on the assignment itself. Okay, there are 3 questions on assignment 7.4 part 2. I'm going to have you do number 1 and number 3. Okay, so you are assigned to number 1 and number 3 for assignment 7.4 part 2. Okay, question 1 and question 3. This one right here you can do, but if you'll notice, as soon as we subtract 12 on both sides, we're going to end up taking the square root of a negative. And we in Algebra 1 say that that means there are no real solutions. That is an Algebra 2 concept known as imaginary numbers. So we're not going to do that. All right, guys, have a great Wednesday and a great Thursday. I'm thinking about you all a lot. I love connecting with you via email and the back and forth on the different assignments. Get your stuff done. And I'm excited to hopefully see you all on Friday at 1 o'clock. All right, take care. Bye.